So today we're going to complete our discussion, a brief discussion about the climate. And we saw last time that the Intergovernmental Panel on Climate Change said that there were four main reasons why the Earth's climate changes. It changes because of differences in the amount of energy emitted by the sun, the amount of energy reaching the Earth, the amount of reflection of energy from cloud and ice, which we saw last time was called albedo, and finally because of the greenhouse effect. And it's the greenhouse effect that I'm going to talk about. Let's talk about greenhouses in general. Why does a greenhouse keep warm inside even without a heater? The reason is that the glass allows sunlight to enter, but once the sunlight energy is inside, it gets absorbed by plants and other things in the greenhouse and is then re-emitted not as light but as radiant heat. Glass will not allow radiant heat to pass through, and so the heat is trapped inside. It reflects around the glass and keeps the greenhouse warm. This is called the greenhouse effect. Now we have the same effect for the whole Earth. Some of the gases in the Earth's atmosphere have the same effect as the glass in a greenhouse. They allow the sunlight through, so it warms the surface of the Earth and is sent back out as heat. But these gases will not allow the radiant heat to escape, so it is trapped close to the Earth and keeps the climate warm. So which are these so-called greenhouse gases in the atmosphere? We have already seen that 99% of the molecules in the atmosphere consist of nitrogen and oxygen. These have no effect upon light or heat passing through, so they do not cause the greenhouse effect. It is only the other 1% of molecules, shown here as white, which cause this greenhouse effect. But which molecules are they? What are the greenhouse gases? The most important greenhouse gas is water vapour. This does not include the water in clouds, which is in fact held as tiny droplets of liquid water. Water vapour is an invisible gas and is the most important greenhouse gas. Another one, and the one most people know about, is carbon dioxide. We will come back to talk about that later. Methane is another important greenhouse gas. It is released by industry and by farming. And another one is nitrous oxide. Some is created by nature, some by fertilizers, some by vehicles and some by industry. Far more attention is given to carbon dioxide than to any other of the greenhouse gases. Why is this? The Intergovernmental Panel on Climate Change, the IPCC, compared the warming or cooling effects of many climate change factors between 1750 and 2005, some man-made, some natural. They calculated the net change in the amount of energy reaching the Earth's surface attributable to each of these factors. This diagram shows their results. Some factors tended to warm the Earth, some to cool it. Of all these factors, carbon dioxide, shown here in red, had the highest warming effect. So carbon dioxide contributed more than any other single factor to climate change between 1750 and 2005. That is why it is so. 1750 is a key date in the history of human influence on our climate because it marks the start of the Industrial Revolution. Before that date, the amount of carbon dioxide released from the land and from things living on the land was roughly equal to the amount of carbon dioxide absorbed from the atmosphere back into the land. This diagram shows that about 120 gigatons of carbon used to flow in both directions every year before 1750. Likewise, the amount of carbon flowing between the oceans and the atmosphere was roughly in balance, about 90 gigatons per year. So, up to that date, carbon dioxide had little influence on the climate. The most important effect, as we have seen, were the Milankovitch. In 1750, humans began burning fossil fuels, originally coal and now oil and gas. Today, this releases about 5 gigatons of carbon per year into the atmosphere. This is in addition to the 120 gigatons that flows between them from natural causes. About 2 gigatons of this is absorbed by the oceans, but the other 3 gigatons accumulates in the air every year. This is what causes global warming today, which we will talk about in the next